As you're plotting these coordinates, talk to me about what you notice. Okay. Do you notice anything? Do these points make a perfect graph? No. They do not. However, do they kind of look like something? Yeah. What do they kind of look like? Hold on, what did you say? A line. They kind of look like they could be a line. Is it a perfect line? No, but you can kind of see how there's a trend, if you will. Okay. Joey was making comments while we were getting our data points. Like it wasn't a surprise how long it took. Like it made sense that after 2 people took 5 seconds, 3 people took 8 seconds, 4 people took 11 seconds. What was he noticing? What feature? And what do we call a constant rate of change? Slope. Okay. Now, this is what we call a scatter plot. And we're not going to connect the dots. And if you have already, I'm sorry, but you're going to need to erase those. Okay? We're not connecting the dots, but these points are telling us a story about what's happening. We can make some estimations with this data, and we will, okay? But we can tell that it's modeled in a linear trend. It's not perfectly linear, but we can use a line to approximate what is happening, okay? So let's just talk about if we were to use a line to approximate that data, what kind of slope would it have? A positive. It would have a positive slope. Jace, how do we know that it's positive?
Because it's going up.
Because it's going up. We're going to come back to this document, but just real briefly, could you turn into your student journal to page 113? There should be some in this purple extra drawer right here if you want to grab it, okay? Okay, so on our scatter plot, it's basically a bunch of coordinates, okay? But I'm going to ask you to give me correlation. Correlation, okay, is basically if we have a trend, okay? So we could have 3 different kinds of correlation. We could have positive correlation, like we did in our hula hoop thing, where we have a bunch of coordinates that look like they have a positive linear trend, okay? We could have, what am I going to call this, you think? Negative, where our coordinates look like they have a linear trend but with a negative slope. But then it's also possible to not have a trend. basically the pepper spilled on your page and you have dots everywhere, it doesn't look like a line, so we're not going to have a trend. There's no correlation. Okay. Okay. So on the next page, this page 114, can you tell me what sort of correlation this has? This has positive correlation. Okay. Now, our x-axis, our independent variable is age, and our dependent variable is weight. So I'm going to come to question C first. What tends to happen to the weight of the baby as the age increases? So as we get older, what does this graph say about the weight?
It gets bigger.
Okay. As age increases, weight increases. What feature of our graph is that referring to?
What do you do?
Yeah, our positive correlation, which is talking about our general idea of the slope, is how we know that our weight is increasing with age. That's basically ask you to interpret our supposed slope. Okay, now can you read a graph? What is the weight of the baby when the baby is 4 months old?
It's 14.
Here's 4,
14 pounds.
so 14 pounds. Oof. Okay, now what is the age of the baby when the baby weighs 17.2 pounds? So here's 17.2, like right there, that blue dot. So we're talking about 8 months. Okay, cool. So you can read a graph, right?
For the most part.
Well, except for some points where like it's not.
Okay.
As you could say that.
So you and your partner, I want you to look at these 4 graphs and determine what kind of correlation is happening.
I think I just realized if you look closely at the graphs, you can see how some of the dots form a shape.
Yeah.
Number 3 almost looks like a sombrero.
Thank you. I have not been very good at figuring out where I leave this. Okay. Willa, what do you think about number 2? Positive correlation. We could draw a line with positive slope and estimate what is happening. Do you see how I drew a line and some of the dots are on it, some of them are above, some are below? That is estimating what's happening here. Okay? What about number 3? Connor, what do you think's happening with number 3? All right. We have negative correlation because we can estimate our data with a line that has negative slope. Okay? We are not connecting the dots to make a crooked whatever. Okay. All right. David, what do you think about number 4?
That's no correlation.
There is no correlation. The pepper spilled on my coordinate plane. There is no trend. The data is telling me nothing. Okay? And then everybody, what about number 5? Positive. The data is telling me that as X increases, so does Y. Okay? All right, so let's go back to our hula hoop. Okay? Literally the only thing you're going to have to do is be able to tell me what kind of correlation, and then like the baby in pounds, being able to read the graph. Okay? Yes.
Is this all the unit is? Sorry, my fault. Is this all
Means the lesson.
Yeah.
Or is it like actually?
So what I want to do is I want to take this lesson and I want to connect it to everything else we've done in the chapter, except maybe parallel perpendicular lines, okay? What I want to do, and you'll notice on the back, okay, we're going to actually draw a line to approximate what this data is telling us, okay? So let's go to the back real quick. We have already decided that our independent variable was the number of people, and the dependent variable was time in seconds. Okay? And we have decided that our scatter plot has what kind of correlation? Positive. Okay. So what I'm going to do is I'm going to pick 2 points to connect to make a line to approximate our data. Does anybody have a strong feeling about which 2 points we should draw a line through? Okay, so if I draw through the first and second one, then our line would look like this. Do you think that we have an even, the same number of points above as we do below? Well, okay. What if I picked this one? Let's see. Does that look better?
Yeah.
No?
I think it looks.
Does that look better?
Yes. Yeah. A little bit do the.
So these two?
Do the fifth one. Do the fifth one. Okay. Real quick.
I think this one looks okay. Okay. So these are the 2 points we're using. Okay? 2, 5, and 5, 13. So over here, 2, 5, and 5, 13. What I want you to do is find me the slope.
Sorry.
Y2 minus Y1. So what does our slope end up being?
8/3.
Okay. So let's talk about what 8/3 represents in terms of the context to our problem. Remember, slope is rise over run. 8/3. What is that representing?
Rise over run.
Okay. In context of our problem. Okay, and what is the slope? Seconds per person. It's going to take us about 8/3 seconds per person for that hula hoop. Well, 8/3, that would be like, what, 2 2/3, right? So it's taking almost 3 seconds per person. Little bit more than 2 seconds per person. A little bit more than 2.5. Okay? Okay. So now what I want you to do is I want you to pick one of these points, and I want you to write the equation of the line that I drew. So here's your slope. Pick a point. Does it matter which point you pick? It does not. Use point slope form and then get it into y equals mx plus b. You're writing me the equation of the line that has the slope of 8/3 going through those 2 points. This is something you did on your quiz. It's something you got to do Friday on your test. Is it a little bit messy?
Yeah.
Raise your hand if you're using the 0.25. Raise your hand if you're using the 0.513. Okay. So y minus 5 equals 8/3 times x minus 2. Real life is messy, people. It's okay. So y minus 5 equals 8/3 x minus 16/3. Okay. And when we add 5, how many thirds is 5?
15.
15 thirds. Now, does it make sense that when we plug in 0, we get negative 1/3? In the context to the problem, no. When we have 0 people, it's negative 1/3 seconds. Okay, no, that's weird. However, this is the line that is best approximating our data. Okay? Now,
You get the like 1/3.
where did I get the 1/3 from?
Yeah.
Okay. We have negative 16/3, right? And we added 5. 5 would be like 15/3. So negative 16/3 plus 15/3 would give us negative 1/3.
Where did you get the 15?
So I cannot add these two together unless they're both a fraction with a denominator of 3. So if I make 5/1 and I want it to have a denominator of 3, okay, I multiply each of them by 3 to get 15/3. Okay. Now, let's use this to predict how long it would take our entire class. Not everybody wanted to participate. Fine. How many people do we have in here, not including me? There's 27. If we plug 27 in for x, we can figure out how long it would take our whole class to do the hula hoop. All right, I'll tell you that 8 times 27 is 216.
Damn. I mean, darn. So this is just 215.
So that would be 71.6 repeating. So it would take around 72 seconds to get through our whole class. So like a minute, 12 seconds. Okay. Now, let's change this to 700. Let's change that to 700 because that's what I asked you to predict in the first place, right? Let's see who got the closest to what our data shows. Well, you already did guess. That's what I asked you to do at the very beginning. What did you guess right here?
I didn't guess nothing. Let me think some.
8,600 seconds.
All right. What did you guess?
I guess 1,800.
Okay. So if we plug in 700,
I'm gonna say like 60 minutes.
Wait, we're supposed to have 2 minutes? Wait,
1,200 seconds. 1,200.
I said 2,000. Yeah, that's what I 1,200 seconds. No, 1,200 seconds. Or 2,100.
That's like 20 minutes.
Oh, wait.
No, it is not. Wait.
so 1,866 seconds.
I
said 1,200.
Raise your hand if your guess. Hey. Raise your hand if your guess was in the 1,000s.
I don't know where my guess was.
Raise your hand if your guess was 1,800 something.
I ain't know it, bro. No.
Really?
Don't lie.
Nice.
I don't know.
Raise your hand if your guess was like totally way off, not even close.
It was kind of close.
Ryan.
I was 300 seconds.